College's Intermediate Algebra online lectures. My name is Jim Helmer, and today we're going to be talking about section 5.4, which is solving equations with rational expressions or rational terms. And what we're going to use here is some of the things we covered in the last section, in section 5.3 and section 5.2. We're going to determine what the LCD is and utilize this when working with equations. We can solve equations, but we can only simplify expressions, which was the last few sections. So now we're going to look at how we can apply LCDs to solving equations. And the nice thing about equations is we can always check our work and make sure our answer makes sense and makes a true statement. So the first thing I'm going to do here is I'm going to determine what is the LCD of all these terms. Well, we can do that by factoring, but since they're just numbers, maybe we can look at it and say, well, 12 is divisible by all of these numbers, so our LCD here is 12. Now what I'm going to do with this information, now that I know that the LCD is 12, I'm going to multiply every single term by this LCD. So essentially I'm going to set it up as a distribution. I'm distributing it to the entire equation, which means I have to distribute it to each term in the equation. Now there's two ways to do it. I could go 12 times 5 to give me 60 divided by 12 is 5, or I could do the division first. 12 over 12 is 1. It simplifies to 1. 1 times 5x is just 5x. Now I'm going to distribute it to the next term, and I'm going to do that division first. 12 divided by 3 is 4. 4 times negative 2 is negative 8. 12 times this term, the 12 simplify to 1, negative 7x. 12 times the last term, 12 divided by 6 is 2. 2 times this quantity is negative 10. And now, if you assess the problem, there are no more fractions and we have an equivalent equation, which means we can go ahead and solve this. I'm going to add 7x to both sides and add 8 to both sides. I get 12x equals negative 2. Divide both sides by 12 and simplify. Negative 2 twelfths is negative 1/6. Now, it's very important that we check our work, and I'm going to do that here. But I just want to point out, sometimes checking our work can be way more tedious than finding the answer. But it is a good policy to always check your work. Know that you're right. Know that your work makes sense. So I'm going to switch it up a little bit and go with another color, because I have that opportunity on the whiteboard here. What we're going to do is we're going to take 5 twelfths times the x we found, negative 1/6, minus 2/3 equals negative 7 twelfths times our x, negative 1/6, minus 5/6. Now, if we go ahead and simplify this, we can do multiplication before any addition or subtraction. I get negative 5/72 minus 2/3 equals positive 7/72, the negative times a negative, minus 5/6. And even when we're dealing with equations that have fractions in them, we can still use this policy. I can multiply by the LCD instead of changing these to have that LCD. This one I'd have to multiply by 24 over 24 to get that denominator to be 72, and this one I'd have to multiply by 12 over 12 to get that 72. Or I can just multiply everything by 72. That is my LCD here. And if I do that, I get negative 5 minus negative 2 times 24 is 48. Multiply this side by 72, I get 7. And this by 72, I get negative 60. Now, is this a true statement? Negative 5 minus 48 is negative 53. 7 minus 60 is negative 53. Negative 53 is negative 53. That's a true statement. It is what it is. I know that my solution here, x equals negative 1/6, is correct. So, like I said, sometimes checking your work can be more tedious than actually finding the solution, but it's good policy. And we'll see in future examples, at times it is very necessary to check your work when we talk about domain. We can never divide by 0, so we got to watch out for that, especially with rational expressions. All right, let's move on to the next example here. This one here is we see a 6 in the denominator and a 4 in the denominator. First thing we want to do is just assess any problem before we start. We look at it and say, oh, it's just a fraction equal to a fraction. And many of us might say, hey, I know that as a proportion, something we'll talk about in the next section of, or the next video of this section. But we're going to use the policy of what we used here. We're going to multiply by the LCD. And I look at this in 6 and 4, well, they're LCD because this has the factors of 2 and 3, and this has 2 and 2, so I need the factors 2 twice and 3 once, and 2 times 2 times 3 is 12. So my LCD here is 12. Just by coincidence, it's the same as the last one. So I'm going to multiply all the terms by 12. Now 12 divided by 6 is 2. 2 times this quantity. Well, 2 times 4 is 8 times that quantity. On this side, if I multiply this by 12, here it is, 12 times this quantity. 12 over 4 is 3. 3 times this would be, 3 times 2 times this would be 6 times the quantity x minus 5. Now you notice, by multiplying by the LCD and just doing a little bit of simplification, I now have an equation with no fractions in it. So we can eliminate these grouping symbols by distribution. 8x minus 24 equals 6x minus 30. And now I can just get my x's on one side, my numbers on the other, and solve. So I'm going to subtract 6x from both sides and add 24. And I get 2x equals negative 6. Divide by 2, x equals negative 3. Let's go back and check our work. We'll do it the quick way instead of showing all the work. And if you want to work this out, you can. But I'm just going to, for time's sake, negative 3 minus 3 is negative 6. Negative 6 over 6 we can reduce to negative 1 times 4. So we get negative 4 on the left side when we plug in that value negative 3. Here if I put in negative 3 minus 5 is negative 8. Negative 8 over our denominator of 4 is negative 2. Negative 2 times this 2 is also negative 4. This is a true statement. It doesn't get any truer than this. Negative 4 is negative 4. That is a true statement. So let's review the tools that we use to solve these these equations containing rational terms or rational expressions. Here we have, the first thing we want to do is clear those fractions using the LCD. Determine what your LCD is, multiply all the terms by it, and now we have something without any fractions. We can remove any grouping symbols, whether they be braces or brackets or parentheses, by distribution using the distributive property to eliminate those. We can combine any terms and solve for x. What we'll see in one example is sometimes our x's are not single values. Sometimes they're the higher power, such as x squared. Well, hopefully we remember when we see an x squared term, we want to set that equation equal to 0, get all your terms on one side, and maybe try to solve it by factoring. Hopefully factoring will work and we won't have to use other methods. That's something we will explore more in this class. You might be somewhat familiar with that. And then, of course, check your solution. In some of the examples over here, you're going to see when we check our solutions, one of them actually doesn't work. So, it's very important to check your solutions. All right, let's look at some more examples, and we'll utilize this because we know that math is only learned through repetition and doing it yourself, of course, so hopefully you work on the homework. Let's do this one first. We're going to identify the LCD. Well, we have the factors of x and 6 and x, so our LCD in this case to include all those factors would be 6x. So I'm going to multiply every term by 6x. Well, here if I multiply, the x is reduced to 1 and I have 6 times 5, which is 30. 6x times 1 over 6, well, just the 6's cancel and I have 6 times 1, which is, or excuse me, x times 1, because the 6 is reduced to 1, which just gives me x. And then I have 6x times this last term. Well, both the 6 and the x cancel or reduce to 1, leaving me with 23. Now this, hopefully you recognize this, say, hey, that's a very simple equation. I can just subtract 30 from both sides and I'm done. So if I subtract 30, I get x equals negative 7. And I can plug in negative 7 and work it out, but it does work. I'm going to have you trust me on this one just for time's sake. All right, let's look at this one. It looks a little bit different. We notice, hey, I have an x in the denominator as well as in the numerator. This is one I'm going to be sure to check my answer because I can never divide by 0. So maybe you can identify what value needs to be excluded and hope that doesn't show up in your answers when you're done working. But it's always important to check your work, so we will check it on this one. Here we identify the LCD. Well, there's only 2 terms, and they have the same denominator, so this is my LCD. X minus 5 is the only factor in any denominator. One thing you could do, you could just combine this to a single fraction, but you're going to end up multiplying by x minus 5 either way. So let's do it right away. Let's just get into the habit of doing this, and if we're consistent, we'll eliminate the fractions. X minus 5 times this first term, the x minus 5 is reduced to 1, leaving me with 3x. Multiply this by the second term, same thing's going to happen. The x minus 5 will reduce to 1, leaving me with a negative 2. Here, x minus 5 times 2, well, I'm going to actually write this out because 2 times x minus 5 requires a little bit more work than just reducing or canceling. We have to distribute. So let's distribute it. 3x minus 2 equals 2x minus 10. When we distribute that 2, and now I can subtract 2 x's from both sides and add 2, and I have x equals negative 8. Now it's time to check our work. When I plug negative 8 in, I can see, well, negative 8 minus 5 is negative 13. Good thing this isn't 0. If that value made this 0, we're done. The whole problem would be no solution. But that's not the case here. So we get 3 times negative 8 is negative 24. Negative 8 minus 5 is negative 13 minus 2 over negative 8 minus 5 is negative 13, and 2 is 2. Let's see if this is a true statement. Negative 24 over negative 13 minus 2 over negative 13, well, that's the same as negative 26 over negative 13. A negative over negative is positive. 26 over 13 is 2. So this quantity is equal to 2. This is a true statement. I know that this value, x equals negative 8, works. All right, let's move on to here. This is x over x minus 6 equals x plus 6 over 9. And maybe you recognize that as a proportion and you want to cross multiply. That is something we'll look at in the next video. But if you don't do it that way, you can still use this method. What is my LCD? I have the factor of x minus 6. I have the factor of 9. And those are my 2 factors. So if I combine them and multiply both sides by my LCD of 9 and x minus 6, well, when I multiply the first term, the whole factor of x minus 6 can reduce to 1, and I have 9x. When I multiply this term by this LCD, the 9's will reduce to 1, and I'm left with x minus 6 times x plus 6. Now that's something that maybe we can use FOIL, or maybe we recognize it as a special product. We're multiplying the difference of terms here. And if we multiply that, we get x squared minus 36. So I just FOILed this times that. Now, here we have an x squared term. So when we have an x squared term, well, we want to set the equation equal to 0. We want to maybe try and factor it first. So I'm going to subtract 9x from both sides. So I'm going to get x squared minus that 9x minus 36 equals 0. And then we're going to try and factor it. Well, what are the factors of negative 36 that have a difference of 9? Well, if you don't see it right away, you could say, well, I know the factors of negative 36 are 6 and 6, but they don't have a difference of 9. 9 and 4 are factors of 36. They don't have a difference of 9. Well, what about 12 and 3? 12 and 3 are 2 factors of 36 that have a difference of 9. So we can go ahead and factor that to x minus 12, x plus 3 equals 0. And if you don't recall, when it comes to factoring, this sign here, because we're summing the negative 12x and the positive 3x to give me negative 9x, this sign determines the sign of the larger value. So now we can just use the zero value theorem. Essentially what that says is 0 times anything is 0. Well, what value of x would make this factor 0? We can see 12. So I'm going to write x equals 12 here. And what would make this 0? Negative 3. And then I would test those. And both of them do work, just for time's sake, but I'm going to just check. 12 minus 6 is not 0. That's good news. Negative 3 minus 6 is not 0, so that's good news. No zeros in the denominator. So that's one way of, if you're crunched for time, maybe on a quiz or a test, that's what you want to at least try. Make sure it's not a value that's going to make it undefined. And if we did plug it in, like I said, sometimes checking your work can be more tedious than finding the answer. Those solutions do work. Now, I'm just going to clean this up a little bit because I crowded my other problem here. And if you need to see that work, well, one nice thing about the technological age is you can move that little cursor bar at the bottom of the video. Maybe it's right about here right now. You can back that up and you can check that out. So if you ever miss anything, don't hesitate to move it back. Or if you say, hey, how did he go from step A to step B? I didn't catch that. You can always back up the video and take a look at it. All right, now this one here, this one's going to take a little bit more work. Because if we recall in the last videos when we were simplifying rational expressions, we always factored and reduced. Well, in the other examples, there was no need to really factor our denominators, but here we have lots of x's, lots of terms. We should check to see if anything factors. And if we look at this one here, maybe we recognize it as the difference of two squares. 9x squared minus 1 is a difference of squares of 3x and 1. So those are my squares. So I'm just going to factor it here. 3x minus 1, 3x plus 1. The difference of squares. And if I FOILed 3x minus 1 times 3x plus 1, I get 9x squared minus 1. So I did factor it correctly. And now if we look at what are our factors in the denominator, let's find that LCD. I have a factor of 3x plus 1 here and here. And I have a factor of 3x minus 1 here and here. So the unique factors that I have are 3x plus 1, 3x minus 1. These are my LCDs, or the factors of my LCD. So now I'm going to multiply every term by this LCD. Now if I take this and I multiply it by the first term, the 3x plus 1 as a factor reduces to 1, and I have 1 times the remaining factor, 3x minus 1. So I'm just going to write it here, 3x minus 1. If I multiply this times this next term, well, this value is the same as the LCD. So it's both factors will reduce to 1. 1 times 2 is 2. And then the LCD times the last term, the x minus 1 terms will reduce to 1. And I'll have 3x plus 1 times 1. Now, let's be careful because this is subtraction, so we don't want to lose that sign. It's negative 1 times 3x plus 1. So I get negative 3x minus 1. I distributed a negative 1 to that term. So if you missed that, kind of go back and look and try to see that. Work it out yourself so you can see these examples. I try to cut them out due to time's sake. Now, I'm going to get my x's on one side, add 3x to both sides, so I get 6x. Here I can combine like terms, 2 minus 1, and then I'm going to add one more to get my constants on the right side. So I'm going to get 6x equals 2. If I divide both sides by 6 and reduce, 2 over 6 is 1/3. And then I can go ahead and plug this in. This is so crucial that we check this. Because if I plug in a 1/3 here, 3 times 1/3 is 1. 1 plus 1 is 2. So here, when I'm checking it, I get 1/2. When I plug it into here, 1/3 squared is 1/9. 1/9 times 9 is 1. 1 minus 1 is 0. 2 over 0. Well, let's write that down for a moment, and hopefully we say, whoa, hold up on the car wash. When we divide by 0, that's undefined. If any portion of an equation is undefined, the whole equation is undefined. We're stopping right there. We're saying this is not a valid solution. But let's continue anyways. Maybe we don't see it there. Maybe we make some math error or sign error or something. If I put in 1/3 here, 3 times 1/3 is 1. 1 minus 1 is 0. 2 over 0 minus 1 over 0 is not going to give me 1/2 no matter how I look at it. So this is undefined. Okay? This is not a true statement. That means the solution we found doesn't work. Well, what does that mean about the whole problem? It means there is no solution. We can write null set, or we can write out the term no solution. All right? So nothing will solve this. It's not going to be true. All right, let's look at one last example. Here we have two different variables. But all we're going to be asked to do for a problem like this is solve for one of the variables. Let's solve for x. So what do I do to get just a single variable by itself? Well, let's use these properties that we just used. We're going to find the LCD. If we look, we have three fractions in these three terms. And our LCD, we have a factor of 2, x, and y. So my LCD, I'll write it right here, the LCD is 2x and y, all three of these factors. I'm going to use that to eliminate the fractions. Distribute 2xy to each of these terms. Well, if I multiply it by the first term, the 2's are going to reduce to 1, and I get xy times 1. The next term, 2xy times 1 over x, the x term reduces to 1, and I get 2y times a negative 1. So I get xy minus 2y equals 2xy times the last term, the y is reduced to 1, and I have 2x times 1, which is just 2x. Now, our goal is to solve for x. We eliminated the fractions using the method of the LCD, but now I got to get my x's alone. So what I have to do is I have to move my x's, group them on one side of the table, or equation side. Here we have to subtract 2x from both sides and add 2y. So essentially I'm just moving these across the equal sign and changing their signs. But now what can I do? I have x in two separate terms. Well, I can always factor. Try to factor. All semester long in these videos, or if you have me in class, you're going to hear me say, when in doubt, factor it out. Intermediate algebra is all about factoring. If you're weak in your factoring skills, definitely work to improve your factoring skills. All right, and in the text, you can go back to chapter 4, and that deals with factoring and rules of exponents. Very important skills for this class. All right, so let's factor out an x, and that leaves me with y minus 2 equals 2y. Well, now, once we've factored out that x, now that we've recognized that step, we can say, you know what, to get x by itself, all I have to do is divide by x minus 2. So if I divide both sides by x minus 2, I'm going to get x equals 2y over y minus 2. Now, this doesn't look much improved from what we started with, but we did solve for x, and that was the instructions given. Let's solve for x. This has been video 1 of section 5.4. We'll continue the video with proportions in the very next video. Thank you for watching.